Hello and welcome to Physics Academy. My name is Dr. Kanshyam Tejani and let's start class 11 chapter number 3 motion in a straight line, and the topic is covered in NEET JEE unit number 2 Kinematics, and this is a second session of chapter number 3 motion in a straight line. In this session we are focusing on kinematics, that is the study of motion, and majorly we are focusing here speed and velocity. In the previous session we extensively studied about displacement and a distance. If you have doubts about distance and displacement, I recommend you should watch first session number 1 of motion in a straight line. Ultimately हमारा focus जो होगा it is on the NEET JEE and JEE advanced. The questions के answers we will be having and we will have fun together. Let's start. So first, that is a speed, and the second, that is a velocity. So we know that speed is equal to distance divided by time, or distance traveled per unit time. We have taken an example in the previous also. Let's take example again. Here let us have point number A and a person called Kapil. He wants to reach to the place B, right? And he may choose any path. It can be of any kind of path, and the total cover, that is known as distance, the total cover, that is known as distance, and the time required to cover that distance we need here. So that gives a speed. So speed is equal to distance per unit time. If you observe a car, it is having a speedometer somewhere here, so we can identify a speed, right? At what speed we are moving. It talks about total distance. Whereas if you talk about velocity, so it is a ratio of displacement. That means a shortest distance. It is talking about a displacement which is to be considered as a shortest distance, right? So in the case of velocity, that become displacement divided by time. Then here in the last session also we have checked distance and time both are scalar quantities, so ultimate product should be a scalar quantity. That means speed is a scalar quantity. Speed is a scalar quantity. Then here in this chapter we will be measuring average speed, and that is to be considered for the longer time. You have taken the example the same. Kapil is starting from point A and he is reaching at point B. We will measure total distance covered, and we will take total time to cover the same distance, right? So here average speed, whenever we talk about average speed, so that is for the longer time, and we use capital delta T for the longer time. And there is a one more terminology that is also we will be studying, that is instantaneous speed. Instantaneous, that means it is specifying for a particular instant, very short time. That is we are using for a delta T. For example, say for example, a plane, it start moving on a runway, then it take off, it moves. So if you want to have the speed at particular small time during this flight, we can refer to dt, that is a very small. We know that dt whenever used, it is t tends to 0, right, in the mathematics. So instantaneous speed, it is to be calculated when a time duration it is required very short, and because of this time duration the displacement or distance, that is also going to be a very short. Then, so we talk about average speed, and therefore average speed is equal to total distance divided by total time. Average speed is equal to total distance divided by total time. That we all know. It is nothing new. And then for the average speed, the letter is used, a small v or sometimes capital V can be used, fine. Equal to for the total distance s, either s or x or d. These three terminologies are popular. These three terminologies are popular. We will be using during our session mostly as, sometime x or sometime d. And the another one, that is the dimensional analysis. So if this velocity is not having any mass component, so dimension of mass becomes 0. Meter, that means L power 1. Second, which is in the downside, so it is L power minus 1. That is simply understood by everyone. And next is velocity. When we talk about velocity, so we are talking about the shortest distance, that is a displacement per unit time. The displacement is a vector quantity because it required a direction of the shortest distance, and the time is scalar, right? And therefore a product of these two should be a vector quantity, right? The scalar and vector was extensively presented during the last session. You may refer to that. The next is average velocity. So here, very similar to average speed, we need to calculate average velocity. It is again for a longer time, and instantaneous velocity, it is for a very short time, dt. And that for average velocity is equal to total displacement divided by total time. See, everything is similar except here we have distance, and in the opposite side we have displacement. Otherwise, all other items are similar. There isn't any difference. Again, let's solve, or let us understand the topic by solving questions. So question number 1, can speed and velocity become equal? Can speed and velocity be equal? So we know that speed is equal to distance divided by time. And what about velocity? Is equal to displacement divided by time, right? So we have taken an example like point A to point B. If you go in a straight line, a shortest distance, that become displacement, or if you take any other way, that become distance, right? But in the last session, we have already seen the similar example. A person can travel from anywhere, that can be a shortest distance also. And in this case, if person travels from A to B, that become distance and the displacement both become equal, right? So in this case, yes, definitely it can be equal. The second question is that ratio of average speed and average velocity is. Options are less than 1, greater than 1, less or equal to 1, greater or equal to 1. We have seen here distance divided by time. So that become distance divided by time, that become speed, and displacement divided by time, that become velocity, right? So equal, there is some equal. So first option is wrong, second is wrong, fine. Let's see, let's check another two. So we know in the previous session also we have seen, right, the distance is a longer term, but it can become a displacement. can become a displacement, right? So always distance is always greater than displacement, or it can be equal. If you take displacement on the opposite side, right, so it become average speed divided by average velocity, and therefore average speed by average velocity. So speed always greater or equal to 1, right? It always become more than average velocity. So answer D is correct, greater or equal to 1. Let's have question number 3. A person travels 3 meter in the east. So person travels 3 meter east for, so distance is equal to s, time taken is equal to 4 seconds. Right? And 4 meter towards north. So total north, that is upper direction, 4 meter distance traveled, and time is taken 3 seconds. So find average speed and average velocity. Find average speed and average velocity. So now what is equation of speed? Now we everyone know that speed is equal to distance divided by time. So here we need to take total distance. So total distance is equal to 3 meter plus 4 meter, and the time is always total. Time is always total. So 4 plus 3, that becomes 7 by 7. So it becomes 1 meter per second. Right. But when we talk about velocity, so velocity refers to a shortest distance. Let's call this point A, this point B, and that it is to be the distance A to B. So if we know that this become 90 degree, so that become hypotenuse. So if you wanted to have distance AB, that become is equal to side square 3 square plus 4 square, and that become root 25. 5. Answer is 5. So when we talk about velocity V, again it is total distance divided by time. No, it is not total distance, it is total displacement. So displacement is 5 divided by time, 7 meter per second, right? So we have distance and displacement, answer are only there. So speed become total distance by total time, and therefore average speed 1 meter per second. Similar for the average velocity, it becomes 5 by 7. We already checked this, right? Then another question. A person traveling in a straight line moves with a constant velocity v1 for certain distance x, let's call this distance x, and with a constant velocity for the next equal distance. That means distance is equal, that is also another x. The average velocity v is given by the relation. The question was asked NEET 2019, and these are the options. Fine, these are the options. See, we need to understand the question, and then we can solve the problem. Otherwise, it is not possible to solve this problem. So here, person starts walk from position A. Let's have a person moving in this direction, and it travels x with some velocity v1. It travels another half as a v2 velocity. So s1 first half become x, s2 second half become s2. That is understood, right? See, whenever you solve the equation, right, for the 1D speed and velocity, always remember total distance s is always equal to s1 plus s2. Total time also become t1 plus t2. See, s1 plus s2 become only if direction is the similar direction, right? If that is the opposite direction, then don't become s1 s2, especially for velocity, right? For the speed, that become fine, but v1 plus v2 is not equal to v, or v1 plus v2 by 2 is also not equal to v in most of the cases. So don't consider this. Always go with S is equal to S1 plus S2, T is equal to T1 plus T2. Always remember this formula. Right here we are just playing within these two formulas only. So we know that average velocity is equal to total displacement divided by total time is equal to V is equal to S by T. That we know very well. And the total displacement S is equal to S1 plus S2. That also we know. Yes. What is S1? X. What is S2? X. Can we say S is equal to X plus X? So it becomes 2X. X plus X, that becomes 2X. So we got now total displacement. Now we need to find time. We have equation for time. Total time T is equal to T1 plus T2. T is equal to T1 plus T2. So our equation is velocity is equal to S, means distance or displacement divided by time. So here T is equal to V, T is equal to S by V. Can we write T is equal to S by V? Yes. So put here T is equal to S by V, T1 is equal to S1 by V1, T2 is equal to S2 by V2. Do we have total distance? Do we have total distance? Do we have total distance? Yes, total distance we already have. That become 2x. Do we have total velocity? No. V1, no. V2, we don't have. Even see if you see options here also V is given, so we need an answer in this formula. What about S1? Distance traveled during S1, that is x. What about S2? Distance traveled during S2, that is also x. Fine. Put the values here. 2x is equal to x by V1, x are now cancelled, and the solution is 2V. So 1, no, 2 by V, yes, this is the correct answer. So 2 number is the correct answer. So in this manner, we can solve these examples. The thing is, remember is here S is equal to S1 plus S2, T is equal to T1 plus T2, but V1 plus V2 by 2 is not equal to V, or V1 plus V2 is also not equal to V. Condition applies. Question number 5. I think you should pause the video and you should try this by yourself. What is 10? A person covers 3 equal distance. So we have taken 3 equal distance, right? See, always to understand the question, right, I always suggest that you should draw a graph or a plot or a chart or a drawing, right? So it will be much easier to understand the question. What it is meant? It is here a person covers 3 equal distance. Distances are equal, so therefore x for a distance, x equal distances. Talking about equal distances. Then with the velocity v1, v2 and v3 respectively, that means for the first distance that velocity is v1, for the second distance it is v2, for the third distance it is v3. That much is given, we need to find, right? Now remember two things. One is t is equal to always total time t1 plus t2 plus t3, and if it is a straight line, so s also become s1 plus s2 plus s3. In the average velocity, we just need this. I see in the case of when we talk about a straight line distance, so velocity and speed both are equal. So if we take velocity or speed, right, it doesn't matter. Both are equal. Both are equal. It become equal in the case of straight line displacement. So s is equal to s1 plus s2 plus s3. Can we write 3x? Can we write 3x? Yes, of course, sir. Great. Then what about time? Total time is equal to t1 plus t2 plus t3, and we already know that v is equal to s divided by t. Therefore, t, what is t? T is equal to s by v. Can we put this here? Yes, sir. Put it. So t become s by v, t1 become s1 by v1, t2 become s2 by v2, like that, right? Now let's put values as we have s, yes, 3x. Good. S1 x, S2 x, good. And what about S3? That become also x. Right? We don't have any other solution other than this. Put this value, x should be cancelled, then 3 by x, and we can solve this, right? That become 3v1 v2, and the v become in power. This is the solution. This is the solution. Yeah, seems much easy. Yeah, don't you think so? Question number 6. I think pause the video. Why don't you pause the video and solve by yourself? Remember that if you solve unsolved example, that will build the confidence, right? And if you solve so many examples which are unsolved, that means you understand the topic correctly. And also every correct answer bring a lot of joy. So question number 6 is given: a person traveling in a straight line moves with a constant velocity v1. So person is starting from this position, great, moving with some velocity v1 from point A to B, and returns from B to A with velocity v2, right? So it may possible that, right, when you at beginning we have a higher energy, we run fast, we can run quicker. At returning we may have some tiredness, and tired person may slow down. That is possible, that is natural. Find the average velocity and average speed. See, average speed, that means total displacement divided by time. Total displacement, starting person starts from A position, person returns to A position, so displacement, there is no displacement, that becomes 0, right? So displacement becomes 0, that means average velocity, that becomes 0. Average, not speed, but average velocity become 0, right? So we just need to get the speed. So speed is equal to total distance divided by total time. We just need to remember these equations for the speed. So total distance s1 plus s2. Remember that why total distance is not s1 minus s2, because that distance is a scalar quantity. It is not a vector quantity. So you just need to have summation s1 minus s2. That is a wrong answer. Total distance means person moves from A to B and he returns from A to B, B to A. That becomes total distance is to travel. Say for example, if you travel from Ahmedabad to Delhi and you travel 1000 kilometer, you return back to Ahmedabad again 1000 kilometer. So your total travel is not a 0 kilometer, that become a 2000 kilometer. That is the principle we need to consider here. So distance is travel same. Let us assume this distance is x. Returning also the similar distance. 1000 plus 1000 become 2000, and here x plus x become 2x. Right. What about the second? Yeah, we always go with s is equal to s1 plus s2. T is equal to t1 plus t2. That is universal now become. So t is equal to t1 plus t2. Time required for that, and we know that equation for t is equal to s by v, t is equal to s by v, right? V is equal to distance divided by time. So we can change this. Put this value here. Do we have total distance as? Yes, 2x. S1 x, S2 x. Put this value here. Put this value here. And this is the solution. This is the solution. Put x is cancelled out. This is very similar to the previous example we have taken, right? The example was we already taken. The similar examples now it is there. Now question number 7. This is question number 7. A person traveling in a straight line. A person traveling in a straight line moves with a constant velocity 100 km per hour. So person, the V1 is given 100 km per hour the speed, and he returns, right, at a speed of 80 km per hour. Maybe possible that he might have a challan in between from the traffic police. So he now a person runs a car in a speed limit. Great. Find the average velocity, average speed. Very similar to the previous one. But here remember that average, if he is returning that, right? So average speed we need to find, but average velocity becomes zero, right? Average speed we need to find, but average velocity becomes zero. That is fine. But when we talk about average speed, when we talk about average speed, so v1 plus v2 by 2, if we do, so it gives us 100 plus 80 by 2, that become 90 kilometer per hour. If you think that if I drive, right, going forward in the direction at 80 kilometer, and the returning time, if I travel the similar distance with 80 kilometers, right, so my average speed will be 90. If you thought that, then you are wrong. You are wrong here. Let's prove it. Let's prove it. So we already got that equation in the question number 6, right? If you join the question number 7 directly, so I simply suggest that you go to question number 6. That equation is already proved. Put the value v1 is equal to 100, v2 is equal to, right, 80, and answer is 88.89, which is less than 90 kilometer, right? So average is not answer. Don't make such mistake in the NEET and JEE. One answer definitely will be there, 90 kilometer per hour will be there, right? And that is wrong answer, but you will select wrong answer by taking shortcut. Shortcut is not good. Oh, escalator. Question number 8. I think you should pause the video. Why don't you solve it? Do it. So question number 8, it is Preeti reach the metro station. Now the metro stations are very advanced. Wow. Found the escalator. Wow, escalator was not working. Yeah, it is usual. As usual, it is not working. In the example also, it is not working. In the reality, we may see, but in here, in the example also, it is not working. So she walked up the stationary escalator in time t1. So this is the accelerator. She is somewhere here. Right? She was in a hurry. Escalator was a stationary. So she moved up, walked up, and her movement time, she need t1 time to reach from this position to this position. Let's have distance x. Fine. On the other day, if she remains stationary, on a moving, oh, now it is working. Now she must have registered a complaint, and yeah, someone got listened. Wow. And it is resolved within a day. Wow. Excellent. So now in the next day, let's change the color, right? Ready for the next day. I think green will work fine. Then the escalator takes up her in time t2, right? So if she walked on the escalator and she moves on the upper side, and that is taken by t2. That means t1, it is time taken by her when accelerator is not working. That means time taken by her alone, that is t1. And on the second case, time taken by accelerator, because she is not moving, she just on a stationary condition, and therefore it is a t2. We need to find the time taken her to walk up on the moving accelerator. That means both she is now starting walking, moving upper direction, plus accelerator, both are going up. So means what? Velocity here we need to take a total velocity. Yeah, you told me that there is no v1 plus v2, but this is the case where v1 plus v2 it is there, and velocities are not for the same person. Here velocity, it is for one is for the accelerator and second is for this person. So average speed is equal to total distance by total time. See, whenever I talk about velocity and speed, and for a linear path 1D, both are equal, there isn't any difference. Fine. So average speed of walking, when she was walked, average speed v1 is equal to total distance she is traveling s, and s big s by t1. T1 is the first time she is going when escalator was not working. It was not working condition. Second time, right, on the next day, she was there. This color is not visible. Let's see another one. Average speed of accelerator. So next time accelerator was working, and that is a speed. Velocity is equal to distance total travel is s, total travel the similar distance s, and now she is taking this as a t2. Great. So now time taken when she walks over on running, that means accelerator also moving and she is also walking. She is walking with velocity v1, accelerator is moving with velocity v2, right? With we assume that she is having similar intensity like a previous day, right? She wanted to go hurry in her life. So t, total time, total distance divided by v. So here velocity become v1 plus v2 because both are moving in the same direction. Therefore, both are moving in the same direction. Therefore, this is answer. You take t on the side and that become a total answer, right? So, see, there were four options were also given. I just taken out these options, right? So we can solve it easily. Question number 9. Interesting question. I think this kind of questions was solved previously. Why don't you try? I think you should try it. So let's solve. A man traveled. A man is standing here somewhere. Short man traveling half the distance. That means let us assume this distance half the distance, that is x, with velocity v0, with the velocity v0, that half distance traveled with velocity v0. The remaining part of the distance means remaining half, that total distance become remaining half, was covered with velocity v1 for the half time, right? So that become total distance become x from this position to this position, fine. And for the half time, that means here talking about t1 and t2, right? Here both are equal, half distance, half time, right? So it is both must be equal, half time it is taken. And the velocity v2 for the other half of the time, right? So she is walking with velocity v1, then next is a man, sorry, not she. Yeah. Gender difference we have to consider. Find the average speed of the man. Average speed. We need to find out average speed. Average speed here total is x. Average speed. So we know speed is equal to total distance divided by time. V is equal to s by t meter per second. That's good. Now let us just consider this distance. This distance total is s. Right, for this instant, right, let's say something s. S1 plus s2. Now v is equal to s by t. If you take v in the power, so s become v t. Great. TV. We don't watch TV too much in this examination. You can have a look on TV, but don't stick there. So x is equal to t1 v1 plus v2. X is equal to t1 v1 plus t2, because what it is mentioned that time required for the BC and CD both are equal. That means T1 is equal to T2. So T1 and T2 both are equal. So you can take this T1 as a outside. You can take T1 as a outside, and then you can take a T1 as a on the power. Fine. So that is one equation. We got one equation here. Another is that we need velocity, or the speed is equal to total distance divided by total time. So we know that s total distance is equal to s0 plus s1 plus s2. S1 plus s2 is x, s0 is also x. So can we say 2x? Yes, of course we can. And total time, total time here it is taking t0, here it is taking t1, here is also it is taking t1. Both are equal. T1 is equal to t2. It is second. So can we say total time is equal to t0 plus t1 plus t1 t2, that is t1, so it become 2t1. Similar here, right? T0 divided by 2t1. Just resolve this. Just here, if you wanted to have t0 time, t0 time. So what it become here from this s divided by time. For this short distance x, it is x, t is right. So it is a velocity is a v0, velocity is a v0, velocity is a v0. Put this value here, just solve this. Mathematics, I don't think I need to teach because you are excellent in this kind of solution. And then you got a final solution. V is equal to 2 V0 V1 plus V2 divided by V1 plus V2 plus 2 V0. Excellent. Great. Great job. And this is a question number 10. Consider a train moving from station A to B. Let us assume this is station A, this is station B, with a constant speed 40 kilometer per hour for the half time. For the half time, it is taking 40 kilometer per hour and 30 kilometer hour for the next half time. That means something talking about time. It is taking equal time on both the interval. Calculate average speed of the whole journey. Calculate average speed of the whole journey. So we know that speed is equal to distance by time, v by t, and here given data, this is v1, this become v2. It is very simple. So we use equation s is equal to s1 plus s2, t is equal to t1 plus t2, that becomes 2t, right? You can write capital T, just avoid confusion. And we can convert this into v1 t1 s. From this equation, s is equal to vt or tv. Put the values here. T, you can take t or you can take t by 2. For the total time, you can take t. That is also fine. You can go with that. Take t2 outside, take t2 outside, or t outside, t by 2 outside, whatever you can write. v1 plus v2 and average speed, right? So this become distance, total distance become t by 2, v1 plus v2, v1 we have, v2 we have. So now average speed is equal to total distance by time, total distance we already have, total time, that is also t. So t by t is cancelled out and then become v1 plus v2 and average speed is 35 kilometer per hour. Right? So in this case, if you see, average speed is v1 plus v2 by 2. In the previous session, I already told that v1 plus v2 is not equal to v. But in this case, when it is taking equal time, only in this case, this is true. Otherwise, for all other cases, this is wrong. Right? Remember that part. When equal time is taken, in this case, you can take average. Otherwise, it is never equal average. So question number 11, you can take this question, solve by yourself. Why not? The similar questions were solved previously. A particle travels half the journey, at speed 2 meter per second. This is V1 is given for the second half of the journey. Particle travels with the speed. This is V2 for half of the remaining time and for half. So that means what time? Talking about half of the time. Half of the time. This is V3. Here time is equal. Distance is not equal. S2 and S3 are not equal, but time is equal. And for the other half, it travels with the speed 6 meter per second. Fine. Find average speed. Speed is this. Velocity is given 2 meter per second. V2 is given 3 meter per second. V3 is given 6 meter per second. T2 and T3 both are equal, right? So you can take time is equal to T. S1 is equal to 2S, that distance is given, and the total distance is also given. Total distance is also given. The similar distance it is traveling, right? It is mentioned that half of the journey, that is a half journey. That means it is a second half. Yes, both are equal, right? So this is given data. This is a given data. Always note down all the given data, as well as we should construct a valid drawing to understand the problem, and then it become very simple. That become easy go. So first half, S1 is equal to V1 T1. Can we say S1 is equal to V1 T1 from this data? From this, S is equal to VT or TV. Fine. So S1 V1 bar V1 T1, that is T1 is given 2 second, V is right, that is also given. So here S1, V1, T1, S1 is given, S1 is given 2S and V1 is also given 2 meter. V1 is, so ultimately T1 and S1 become that. Let's put this equation one. Time required for this interval, that is equal to S1 second, S1 second, S1 second. Good. For the second half, we are talking about this half, so that is having S2 and S3. S2 plus S3, we can convert this equation in terms of TV, T2, V2, T3, V3. And in this case, time is given for T2 and T3. Both the cases, time is given T2 and T3. Both the cases, time is given T2 and T3. Here, time is T, here, time is T. So put the values here. S1 plus S2, total distance we know it, that is a 2S, fine. V2 is 3 meter per second. V3 6 meter per second. Put the value time T1 and T2 both are T. So that become 90. And S2 plus S3 is equal to 2S. That means you can find the T from this 2S by 90. So that time refers to T for this position, this two position, right? Now we know that average speed is equal to V S by T. S is total distance. Total distance we have 2S plus 2S, 4S. Time, here it is time that is required for that. We already have this equation number 1 and this is equation number 2. This is equation number 2. So T S is equal to 4S and T1 plus T2 plus T3. T is equal to S. T is equal to S. T small t, that is 2S by 9. T1 is equal to S. T2 is equal to 2S by 9. 2 times, you need to take 2 times. S to be cancelled out. S to be cancelled out. And the final answer is 36. You can solve this answer and you will have a correct answer. So we have solved this question number 11 is now solved. Oh. Question number 12. And that is very similar to the previous one. Why don't you solve? I think you should solve this. What is mentioned? A car travels half distance at speed v1. A car travels half distance at speed v1. So that car, it looks like cab, but it is car. Car travels half distance at speed v1. That is, the distance is half, and the remaining half at v2. Let us assume total distance is equal to 2s, right? So it is become simple. So first half it is s distance, second half it is s distance. Fine. Now it is given for the second half, remaining half, speed v2 for the first one third time is mentioned here. For the first one third time, speed is v2, and for the remaining 2/3 times, velocity is v2. Find the velocity and the speed. Find the velocity and the speed of the person. If person is traveling in the same direction, so speed and velocity both are equal. Now, so from that, this s, that become distance is s1, this become s2, this become s3, and we know that total half distance it is taking. The half is taking in this side, half is taking this side. So become s1 is equal to s2 plus s3. That is simply none. Then second part is given. Time taken. Car travels half distance at speed v1, and the remaining half, that means total time t2 plus t3, that is half. So it become t. That become t. Fine. So we know that for the first half, we can convert this equation. V is equal to S by T. So S is equal to V T. We can put here S1 is equal to V1 T1. S1 is equal to V1 T1. And we can take T in the power. For the first half, distance is taking S. For the first half, distance is taken S. So we can put here just S. V1 we don't know. Velocity we don't know. We have no idea about velocity. So we just put V1. For the second half, S2 plus S3. For the second half, S2 plus S3 is equal to again S. Right. Put the value here. S2 is equal to T2 V2, like similar to this one. S3 is equal to T3 V3, similar to the previous. Fine. Then T2, if the time is taken here, so this second half is T. If it is taken T, so it become 130 the first half, and that time become 230. So we can put T2 is equal to T by 3, 130, and T3 is equal to 2T by 3, 2T by 3. Yes, good. So simplify it. So S is equal to T by 3, V2 plus 2V3. Right, you can just take time as a one side, so it becomes 3S divided by V2 plus 2V3. Now time for speed. Total S is equal to S plus S 2S. Total time T1 plus T2 plus T3, and here that is average, we know that T, right? So it becomes T1 plus T only. T1 plus T only, put here T1, T2 plus T3 is equal to T. Put the value of T1 this here. T1 is equal to S by V1. T2 plus T3, that become T, so it becomes 3 as V2 V3. So equation number 1 and equation number, so equation number 1, you take equation number 2, put the values here, and you will be having solutions in this case. So thanks for watching Physics a Doctor. Have a nice day.